Okay, now we are going to state the reference angle for the following. So first I need to find it. 168 degrees is probably about here. So what I'm going to do is I need to find my reference angle. So that means I need to find the distance from my 168 to my 180. If you remember back to geometry, the degree of this arc, the distance of this arc, is going to equal my angle right here. So if I find the distance, or the difference, which means I'm going to subtract between 168 and 180, I'm going to get 12, so my reference angle is 12 degrees. 224 is going to be really close to my 225. Now my reference angle, remember, I always go to my x-axis. I'm not going to go here to my y. I always go to my x-axis. So what I want to do is I want to find the distance it takes to get from here to here. So I'm finding the difference between 224 and 180, and I will get 44 degrees. Remember, I'm finding the difference. This is not going to be a negative number. This is still just going to be a reference angle, and so therefore it is a positive 44 degrees right here. 323 is going to be about here. And so I want to find my reference angle. I go up to my x-axis. Now, I'm not going to use 0. I'm going to use 360. So I'm going to find the difference between 360 and 323, and I'm going to get 37. So that is going to be 37 degrees. Okay, now I'm going to find my reference angle for 81. 81 is probably going to be about here. Now, if I have any angle in this first quadrant, I'm just going to subtract from 0. So 81 minus 0 is going to give me 81. So it's going to be whatever that degree is. If it's in the first quadrant, is still going to be my same thing for my reference angle. Now, pi, radians. Oh, you guys hate this stuff. I could convert it to degrees, get my answer, find my reference angle, then convert it back to radians. Have fun if that's what you want to do. It will be a pain, but if that's the only way you know how, then do that. But it is about time you guys learn fractions. It needs to be done, and it's so much easier. Okay, negative 2 pi over 7. That means I'm going to go this direction for 2 pi over 7. Okay, so if I go backwards, I know this is pi over 6, and this is 2 pi over 6. 2 pi over 7 is going to be a little bit less. So it's going to be probably about right here. Now, when I went backwards and I went negative 2 pi over 7, remember, for my reference angle, I want to find the distance between my terminal side and my closest x-axis. Well, here's my closest x-axis. So it doesn't matter what the positive degree is, because I just want to know what this is. It's in 360. So whatever this positive degree is, minus 360, I'm going to get the difference, which is right here. But remember, my reference angle will be positive. So that's how I get 2 pi over 7. Now, for 21, 5 pi over 6. If I ignore my 45 reference angles, all my pi divided by 4, if I ignore these, then each of my line goes by pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So my reference angle is going to go down towards my x-axis. Well, if this is 5 pi over 6 and this is pi, what do I need to add together to get pi? Or to get 6 pi over 6? I need to add a pi over 6. So the difference right here is going to be my pi over 6. So my reference angle is going to be pi over 6. Okay, a tough one that you guys had on the quiz that you guys all got wrong was negative, no, I'm sorry, that's the wrong one. Okay, I'm sorry, this is not from your quiz, but I'm going to go ahead and make one up. Negative 7 pi over 6. Well, again, I'm going to ignore my red. So I'm going to start here. Since it says negative, I'm going to go backwards. So this is going to be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6. Look at that. I go backwards, negative pi over 6. My reference angle is still going to be the difference between here and my x-axis, which means my reference angle will still be pi over 6.